Hi and welcome to section 12.2. This is the only video for this section, one video of one. So in section 12.2, we're going to be looking at what's known as arithmetic sequences. So arithmetic meaning arithmetic meaning addition. So we're looking at sequences that all have this sort of addition feature. As we go from one term to the next, we're adding a constant value to it. So the formal definition says the following. An arithmetic sequence or an arithmetic sequence is of the form so we have our first term a, and then we add some value, the difference, to it. And then to that we add a plus 2d, then a plus 3d, and so on. So if I start with 1 and I keep going up by 2, it's going to be what? 1, 3, 5, 7, 9, etc., etc., etc. So I keep multiplying, I keep adding the same value as I go from one term to the next. So the number a is the first term D is what's known as the common difference. And then we have the following, the nth term, and this is the piece you're going to want on your cheat sheet, the part you're going to want to memorize for the final exam. So the nth term of an arithmetic sequence is given by a of n is equal to a, our starting value, plus n minus 1 times d. So let's look at an example how we can apply this. So if a equals 2 and d equals 3, find the sequence. So that means what? A is our starting value. It's 2. 2, not A. Our difference is 3. So when we go from this term to the next term, we have to add, because the arithmetic sequence, 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, and so forth. So that's one example there, kind of just the basic of what this arithmetic sequence means. So let's look at this example. So find the first 6 terms and the 300th term. So this is why that formula is so important. I'm going to tell you right now, this question like this has been on the final exam, and people will actually sit there because they forget the formula trying to write out 300 terms so they can figure out what the answer is. If you have plenty of time, that's great. Unfortunately, you just don't have that kind of time on the final exam. So you need to know that formula. So we want to find the first sixth and the 300th term of the following sequence. 13, 17, and that's all we're given. So we need to figure out our formula a of n. We need to figure out what's going on here. So we know this value is equal to a. But now what's the difference? How did we go from 13 down to 7? Well, we had to subtract 6. So that means what? That means a of n is equal to a, 13, plus n minus 1 times the difference, which is negative 6. So that's how we're going to find the 300th term. The first 6 we can kind of just keep subtracting. So we have a of 1 is 13, a of 2 subtract 6 is 7, a of 3 is 1, we're going to subtract 6, a of 4 minus 5, a of 5 minus 11, and a of 6 minus 17. Excuse me. Those are the first 6. Now for the 300th, we need to use this formula. So we got a of 300 is 13 plus 300 minus 1 times negative 6. So that means a of 300 is 13 plus 299 times negative 6. So that means a of 300, when you do the multiplication and addition, gives us negative 1,781. So I hope you can see how trying to just figure out a of 300 by keep subtracting 6 is a really, really bad idea. The chances of making one mistake are pretty high, and as soon as you have that one mistake, all your numbers are going to be off and you're not likely going to get it. So please memorize that formula for the final exam and make sure you have it on your cheat sheet. All right, so here is another typical problem that you'll see on exam 3, maybe the final exam. So we have the 11th term is 52, and the 19th term is 92. Find the 1000th term. All right, so using that formula, what do we know? Well, first off, it tells us the 11th term. So that means a of 11. So I don't know the starting value. That's a. According to the formula, it's n minus 1. So that means 10, and 11 minus 1 is 10, times the difference, whatever it is. I don't know the difference yet either. This whole equation is equal to 52. So if I knew A, if I knew D, I could plug them in and I'd get 52. Similarly, I have that A of 19, it tells me. Again, I don't know A, but 19 minus 1 is 18, times the difference is now equal to 92. So now what do I have here? I have two equations with two unknowns, so I can solve by either substitution or elimination. In this case, it's easiest to solve by elimination because I can just multiply one of the rows by -1, and that's going to eliminate my A value. So let's do the first one. If I multiply this by -1, I get minus A minus 10D is minus 52. And I leave the second one alone, so A plus 18D is equal to 92. So add down, negative A plus A is gone. 18D minus 10D is 8D. 92 minus 52 is 40. So now I just divide both sides by 8. Tells me that D, the difference from one term to the next, is 5. Now I still need my value for A so that I can generate A of n so that I can figure out the thousandth term. So I'll just use the first equation. So I have A plus 10 times D, which is 5, is equal to 52. So A plus 50 is 52. So subtract 50 from both sides. I get A is equal to 2. So what that means is that A of n is A, which is 2, plus n minus 1 times D, which is 5. So I've used the first sentence to help me figure out what's A and what's D. Now that I have it, I was able to figure out the general equation A of n, and then lastly I want to find the 1000th term. So again, make sure you're answering what's being asked. It's not asking what's the general equation, it's asking what's the 1000th term. So that means A of 1000 is 2 plus 1000 minus 1 is 999 times 5. So you do the multiplication and addition, and you get A of 1000 is 4,997. I'm going to erase this. If you're still catching up, if you were trying to go back and track the numbers, go ahead and pause it. I'm going to give you guys 2 more formulas. That will wrap up section 12.2. All right, so this last little bit I'm going to give you here has to do with partial sums of arithmetic sequences. And what partial sums means is that, let's say I have a sequence and I want to know the sum of the first 10 terms. These formulas I'm going to give you will give you that value. So a common kind of problem you might see would be somebody has a starting salary of $30,000. They get a $2,000 raise every year, so that's our difference, $2,000. And we want to know how much will they have made after 20 years. That's what these formulas are going to do for us. So we have 2 formulas give us the same answer depending on what information we have. So we have S of n, so the sum of the however many terms is equal to n over 2 times 2a plus n minus 1 times d. So this would be the formula we use, like the example I just gave you. The starting, the starting salary is $30,000, that's our A. They get a $2,000 raise every year, that's our D. We want to know how much after 20 years. So n is 20, n minus 1 is 19. That would give us how much the person has made. The other formula for the sum would be n times A plus a sub n all over 2. So in this one, depending if we had to already figure out what is a sub 20, we could use this one. So our n would be 20, a is our starting value, 30,000. A sub n, we'd have to calculate that if we didn't know this first formula. We'd divide that by 2 and then multiply everything together. Excuse me. Again, they give us the same answer. It's just in one case we have the starting and the ending value, and then how many years or how many sequences have occurred. Or the first one is if we just have the starting and the difference, and then we're trying to find the sum. So that's the video for section 12.2. Come on back and we'll deal with section 12.3.